Hello class. So now that you know what an exponential function looks like, we're going to transform them with the different types of transformations we've learned so far. So let's remember what we've learned about transformations of functions. If I have a function y is equal to f of x, here's an equation of the general form of all the different types of transformations I can apply to this function, f of x. So let's recall what A stands for. A stands for a vertical stretch or compression. So if I have a value of 2 in front of my function, that tells me I need to take my graph of my function and stretch it in the vertical direction by a factor of 2. Another transformation that is similar but different is this b value here. The b value is inside of my function and it tells me that I need to do a horizontal stretch or compression. Unlike the a value, the b value is inside my function, and the value of which is shown in the equation isn't what it seems. So if I see a value of 2 inside of my function, that tells me that I need to apply a transformation of a horizontal compression by a factor of the reciprocal of that value, which instead of 2 will be 1/2. If I see a value of 2 or 1/2 in my b value, inside my function, that tells me I need to do a horizontal stretch by a factor of 2. Another transformation is this h value. This h value is a horizontal translation. So it's also inside my function, but it's next to my x value, whereas the b value has been factored out of the x value. So here my h value is, say if it was 2 and my function had an x minus 2, that tells me I need to do a horizontal translation to the right by 2. If instead this value has an x plus 2, that tells me I need to move my graph to the left by 2 units. Then, last but not least, is this value k. It is outside my function and there's an addition to it. So the function plus this value will tell me that I need to do a vertical translation. So if I have a value of function plus 2, that tells me I need to move my graph up 2 units. So this is the general form of all the transformations of any function. But let's look at how it would apply to our exponential function that we're learning in this unit. So far we've talked about how the general form of an exponential function is f of x is equal to r, which is my base, to the exponent of x. So here is my function r at x. So if I look back, my vertical stretch or compression is outside my function. So when I apply it, it's going to be a value of a beside my r. The value of b, my horizontal stretch and compression, is inside my function but outside of x. So I'm going to have b as an exponent, but it's going to be factored out of my x value. Then my h value is inside my function but added to or subtracted to from the x value inside the function. So here is my h value next to my x in the exponent. My value of k is outside of my function, so I'm going to add k outside of the exponent, right? Because the exponent is only the x value. So any transformation that I apply to the x is in the exponent. Anything that's not, like the k and the a, it's outside of the function. Okay? So if I were to write this and recall how this would look like for the exponential function, here is my a value, which is my vertical stretch or compression. Then I have my horizontal stretch and compression, which is my b value, and that's part of the exponent. Then I have my horizontal translation, and that's inside my function as part of the exponent. And then I have my vertical translation, which is my k value, which is outside my function. So this is the general form of transformations that can be applied to an exponential function. Please be familiar with all these different transformations and be able to recognize them from an equation. Good luck!